Guys, and welcome to this video for option A, freshwater, flood case study and urbanisation. In this video we'll be focusing on Sustainable Development Targets 13.3, which is building knowledge and capacity to meet global climate change, and Target 11.5, which is to reduce the adverse effects of natural disasters on urban communities. So for our case study, we're going to look at a place called Cockermouth in the UK, and it was flooded in 1999 and 2005. So you can see flooding there is a reasonably frequent experience for the place. On September the 19th November 2009, the Lake District received a lot of rain. It actually received 316 millimetres of rain, and that was the highest amount ever recorded in the UK for a single day. Obviously this had big implications for flooding and caused problems downstream. Before we move on to the next slide, have a think about what you can see in this slide. This is the upper course of the river that goes into Cockermouth. If you look at it, have a think about what physical features would increase the risk of flooding. So here, the Meteorological Office in the UK suggested that the flood that we're talking about in 2009 was a 1 in 100 year event. We've already talked about the concept of what exactly a 1 in 100 year event means. The 2009 floods affected most of Cumbria, from the Eden Valley in the east to Allerdale in the west. For higher levels, your essay should show that there is a combination of factors. Starting at the easiest combination of factors to think about, it's the combination of physical and human causes. We have already looked at the role of urbanisation, and you can see here that towns such as Cockermouth and Keswick have increased the amount of impermeable surfaces. This means that little water sinks into the soil and the river channel fills up more quickly. We've already looked at hydrographs and considered the impact that impermeable surfaces and urbanisation would have on hydrographs. But as always with most floods, it is actually an interaction of several factors that cause the floods to occur. One thing that did happen here in this case study is a lot of the sewage pipes were blocked up. Here you can see a sewage pipe in the area that is blocked up. Quite often these are blocked up with things called fatbergs, which is accumulated cooking fat. This reduces the efficiency of the drainage network and would increase the likelihood of flooding. In addition, there were physical causes. During the 7-week spell running up to the flood event itself, there was 7 weeks of intense rain, above average rain, and this was because of a series of Atlantic depressions that came into the UK. This resulted in a prolonged period of stormy, wet weather. Have a think about what effect this would have on the soil, and specifically the saturation rate of the soil. Secondly, as we can see, there are different factors interacting with each other. There were exceptionally high sea surface temperatures around the Azores. So as well as the fronts coming in from the Atlantic Ocean, it was very, very warm down in the Azores. This increased rapid evaporation. This evaporation travelled as clouds to the UK. So here you are familiar now with a hydrograph, and you might want to remind yourself about the component parts of a hydrograph. So Camerton in West Cumbria, there's a 24-hour flow of the River Derwent was 561 cumecs, and it peaked at 700 cumecs. That's 20 times greater than the average. This is going to give us that 1 in 100 year event. The floodwater in the town centre actually reached a depth of 2.5 metres. This, as a 1 in 100 year event, would be challenging for any type of conventional flood protection network. In the first slide, we did look at the Lake District, that is the upper area of the river basin. So here you can see that we would expect rapid runoff because we've got steep slopes, impermeable rock, thin soil, and sparse vegetation. In addition, we do see this combination of several factors, in this case several physical factors. So we've had the prolonged periods of heavy rain over 7 weeks, plus on top of that the exceptionally heavy rainstorm. This resulted in the soils being saturated so they could not absorb the rainwater. So this increased the amount of runoff into the river. You can quite easily imagine what the consequences of this would be on the river's hydrograph. Again, in the upper course of the river, there are a number of lakes, some of them natural, some of them artificial. So for the first 3 weeks of November, these lakes, here we can see Bathurnswaite Lake, and there's Derwent Water as well. They were full to bursting points. So normally these lakes would act as a buffer. In fact, these lakes have been artificially enlarged to act as a buffer and to store water. So the buffering capacity of those lakes was reduced to zero, and really the rain had no place to go. The result then, of course, is inevitable. So there were significant impacts of the flood. Here, 2,200 properties were flooded. 4 out of 5 of those properties were homes. Bridges were destroyed, and other bridges were temporarily closed. For this unit of work, the examiner would expect you to be able to put these into categories or groups. Categories that you could use are infrastructure, social, economic, political, environmental. But also the better candidate would show how these factors do interact with each other. So, as we said, this floodwater actually reached a depth of 2.5 metres, and the word that you need there is inundated. This community was inundated. As we have said before, this is a 1 in 100 year event, and a flood level of 2.5 metres will be extremely difficult for any flood protection system to deal with. So when we're talking about managing these floods in the future, we're not just talking about flood prevention. We're not just talking about stopping the flood, we're also talking about increasing the resilience or the capacity of the community to deal with that flood if it happens, and increase their capacity to stop the flood from happening in the first place. That 2.5 metre rise is something that we want to stop rather than hold back. Focus down on to specifics like infrastructure. Here we can see that flood roads were damaged. Here we can see a footbridge in the town was damaged. There is also loss of life in this case. PC Bill Baker was actually killed by this. So as we said, focusing on target 11.5 and target 13.3, building knowledge and capacity to meet climate change and reduce the adverse effects of natural disasters, we can see that there was a flood management scheme that was put into place as a result of this 1 in 100 year event. This reduced the risk of flooding for more than 400 homes. Make the link here between SDG 11.5 resilience and SDG 13.3. which talks about building knowledge and capacity to deal with climate change. One of the specific strategies that was specific to this place was the 120 metre wide, very innovative self-closing flood barrier. And this rises automatically when the river floods. This is a purely automatic process. As you can see, the height of this barrier is not 2.5 metres. So if there were a 2.5 metre 100 year event again, the city would still flood. As a reference point, this flood protection gate is about 1.5 metres. So we can see here the interaction between physical and human factors, both on the causes and the consequences of the flood. We can also see how the community responded to the flood and planned for it. Specifically here, how the community tried to build in resilience as a result of its flood water protection plan. As the UK is a more economically developed country, it is able to afford these expensive flood protection, flood mitigation, and flood prevention schemes. Hey guys, I hope you enjoyed this video. If you have, please leave a comment below. If you found it useful, please give it a thumbs up. We'll be investigating these things in a bit more detail in class. Oh yes, if you haven't done so already, please consider subscribing to my YouTube channel because there'll be more videos on the way to help you with your IB examination.